So you guys have given it a good try. Now let me give you the actual definition of CI. Don't worry guys, we'll be having this, what you can see, PPT with you. So I just want you to do this activity so that now if you read the definition, you will understand this thing very clearly. So a confidence interval can of course be calculated by many statistical parameters, not only for mean value. It only says in which range the parameter lies with a certain probability. Okay, for the population. One thing is missing. You can say for the population. Okay. Now we are going to find the confidence interval for the data set given to you yesterday, the Glaxo and the BML data. Okay. Chalo. Let's move forward. Let's open the Jupyter Notebook. I hope nobody is having any sort of question. Chalo. Let me stop the share. Let's minimize this. Salama, that is correct. That is the same as the Z-score. Okay. That's why I'm leaving it right now. This was our notebook, right? Let me run all the cells. So guys, please open your standard normal distribution notebook. Now you guys can connect the dots, right? What is actually happening? We picked up one distribution, which is SND or normal distribution, you can say. Okay. What we have done, we found the descriptive statistics for the SND. Now we are starting with the inferential statistics for SND. Okay. And the first concept is the confidence interval. Okay. Here we got started. Z-score will be depending upon the one tail or two tail, right? So understand that what I told you. Point number one, once it is SND, okay, we are already considering this as two tail. Getting it? So the CI which we are finding or which we can always find is going to be for the two tail graph. And that's why the value was 1.96 at the constant for 95% interval. Okay. When we are going to talk about Z-score now, guys, then we will see what is the one tailing, two tailing, critical region. Here in this case of CI, we don't need to go there. Okay. We are just finding the statistical parameter for the population with the help of SAM. Simple. So that yes, Z-score depends upon the one tailing or two tailing. But here it is given as the constant. Don't worry. We'll open the concept of this critical points, then you will get to that. Okay. Chalo. Question. What was the question? What is the expected range of return for 95% confidence interval? Let me write down the question for you. Just a minute, okay? Let me write down the question number 3. We solved till question number 2, right? Where we first, in the question number 1, we calculated the gain. The second question, we calculated which stock is profitable and which stock we need to invest on. The third question. Okay. Question number 3 says that what is the expected range of return for 95% confidence interval. That's what I told you guys. The value of confidence level is always going to be there written in the question. Okay. Now, 3 things you guys have to answer. Point number 1. It is talking about which statistical parameter. Okay. It is talking about which statistical parameter. Point number 2. It is talking about which column. We are going to find the CI, right? For which column. These 2 things you have to identify. And the third is what is the value of Z score. Chalo. Give me the answers. What do you guys think? What is the statistical parameter it is asking? Okay, correct. Z score, Skype will take care of it. Correct. Okay, Z score value is 1.96 also. Correct. Okay. So since you guys are very close, let me erase this. Now we have to import SkyPy, guys. Okay. So I'm just scrolling all the way up where we import all the libraries, so that is going to look a bit good. Okay. So I'm importing SkyPy here. So simply write from SkyPy import stats. Okay, because as I told you that we are going to take care of statistical analysis, statistical parameters. That's why. So scrolling it all the way down. Trying to solve the question number 3. Guys, this question is going to get solved within 1 line. Okay, so bear with me. One, I am going to solve it for you. Next, you are going to solve it for your own self. Okay. Point number 1. There are 3 different parameters available inside the method. Okay, which method? Stats.normal.interval. That will help you to find the confidence interval. Okay, now guys, do you understand why we are picking 95% confidence interval? Just for people. So let's see if we can save it. Oh, time pass. Sure. You can do this. You can see it is the graph of standard normally distributed data. Can you find something 95% kind of a thing? 68% kind of a thing? Understand this thing very carefully, okay? Since I don't explain the empirical rule because it is very easy to understand, you can do this on your own self, but I trust you guys will not do. Okay? Everybody is very busy now these days. So, I'm not leaving you this for your homework. Understand this. I told you that there are 2 type of distribution, right? When we are having normal distribution, mean is equals to median. There could be any value for mean, any value for median. But when the data is standard normally distributed, what it implies? Okay, it implies that within these standard deviation, what percentage of your data is going to get covered? Getting it? So whenever you want to extract the 68% of data, you can see we are having the 0 coming here. What is the 0 as SND? This is going to be the mean. That will always going to be equals to the median. No problem. Now you can see we are having standard deviation in both the direction. -1 standard deviation, +1 standard deviation. Do you guys understand why mean is equals to 0 and standard deviation is equals to 1? Because we are moving with 1 deviation in every direction, and that is helping me to cover some certain percentage of data every time. That's why we say it is standard normal distribution. Come tomorrow, if I give you one data set of salary, you identify that it is in the standard normal distribution. Suppose I ask you that please extract 68% of the data out of this salary. Can you simply extract this within the -1 +1 standard deviation? Of course. Okay. If I ask you to extract 95% of the salary, can you extract this within the second or plus 2 or second to minus 2 standard deviation? The third standard deviation says we are going to cover 99.7% of data, excluding the exceptions. Okay, they are leaving 0.3 for the exceptions. So this is empirical rule. This empirical rule says that when you are having the data normally distributed, it is how the distribution is going to look like. For 68% is going to fall under first standard deviation. 95% is going to fall in the second standard deviation. And third is your 99.7%. Which two values we were picking for the CI, guys? 95 and 99. Getting it? So can I say that finding the confidence interval of 95% is just moving with, let's say, we are calculating the values for 2 standard deviation away from the mean from both the directions. Can we say that? We are going away from the mean till 2 standard deviation, and within this area, we are going to find the CI or statistical parameter for us. Can we say that? Am I making sense, guys? Okay, so now you understood from where this confidence level came into the picture. Usually we don't choose 68%, guys, because what is the reason? If you move one deviation away from the mean, it is not going to give you any sort of exact answer, which means you are choosing small sample. Okay, now since if you are very close to the sample or the real or actual answer, either you go with the 95% because this is the centermost entry, or either you go with the 99% because it is the lastmost entry in the empirical rule. Getting it? Now, since you want to read some of the lines for the empirical rule, let me scroll this bit down. Okay. Okay, now how to use empirical rule? Okay. Analysts use the empirical rule to predict the probability and distribution of the outcome that they are studying. It's a valuable tool because it lets you make your prediction using several easy to calculate statistics. Getting it? So verify, getting the point, what it is trying to say. You can read this from the website, okay? I'm dropping it down in your chat box. As of now, just for the normal explanation, understand one thing. It is telling you that whenever you have something, some statistical parameters to find, you can take the help of empirical rule or SMD to make the assumptions based on the probability. Okay, so this is the specifically written here. Analysts use empirical rule to predict the probabilities, right? What we were doing, we were predicting the probability of confidence interval, 95% probability, right? And the distribution of outcomes that they are studying. We were studying CI with the SMD. That's why. That's the rule that why we use empirical formula. Getting it? That's how the data is deviated or spreaded in the, you can say, distribution. Any questions still here, guys? Just the basic overview. Now we are going to find with 95% confidence since it is given in the question already. Okay. Chalo. So we have already imported the StatPy. Now the three things which we are going to need. Okay. The first one is going to be your alpha. And the alpha says that interval. It is the interval. Let's say we are calculating this for the 95% confidence interval, right? So it is going to somewhere look like 0.95. Getting it? So alpha is going to be the confidence level. You can say log or location. Location of parameter distribution. In other words, you can say that it is nothing but the mean for distribution. And you guys know the distribution is nothing but the standard normal distribution. And the third parameter is your scale. Okay, standard deviation. Simply we say that scale parameter of the distribution STD, you can say. Guys, understand that here I'm talking about the distribution. It is going to be NB, normal distribution, or SND. Both, anything of them, anyone. Okay. Chal. So first I'm finding it for Glaxo dataset. For BML dataset, you guys are going to find. Okay. Just let me check how my Glaxo is looking like. Just convert this into the notebook. Glaxo underscore. Okay. So this is your gain column. Okay. Now, what we are going to do? I'm simply writing Glaxo underscore DF underscore CI. This is the variable. Inside that, we have a method present in the statistics called as stats.norm.interval. Okay. Inside that, first parameter is going to be your alpha. What is the confidence level? 95%. We are going to mention 0.95. Next thing is your location. Okay. The location is going to be the mean of the column. Which column, guys? Glaxo underscore DF gain column. So simply writing Glaxo underscore DF of gain column dot mean. Simple. Okay. Now the scale is going to be the standard deviation. So simply writing scale is equals to Glaxo underscore DF, the gain column, and dot STD of this. Okay. Running this and now checking the value present inside this variable. Can you see? We are having somewhere value near about 0.025 in the negative end and 0.0266 in the positive end, which means we are having 2.5% in the negative direction, 2.6% in the positive direction. Within that range, we are going to capture the CI, or let's say actual mean of your population. Getting it? Making sense? So you have to go 2% in the negative direction, 2% in the positive direction. Within that desired range, your actual mean is going to lie. Understand this thing very carefully. How I'm going to make this claim perfectly fine. If my original data is in standard normal distribution, which means the population, that's why I was getting the sample is in SND format as well, right? And that's why your CI is coming as 2% or plus 2% minus 2%, near to 0. We are finding mean, right? That's why it is coming near to 0. Making sense? Getting the point? Everything is interconnected. Now find this for BML and drop that in the chat box. I'll be back. And then be ready with your questions as well. Okay, what happened, guys? So can we say the mean of Glaxo gain is between with 95% confidence? Correct. We can say that. Okay. That is very good question. Now let me tell you, this is 0.25. Sorry. Yeah, 0.025. Can I write this as 2.5% in the minus direction? And can I say that it is 2.6% in the positive direction? Okay. Just keep this intact. If you come back here, you will see this. What we were doing, we were picking up the 95% confidence, which means we were finding the range. We were picking up this data set, you can say that usually. Okay. And it is telling you that when you're having the mean here as 0%, what was the actual question? The question says, what is the expected range of return for 95% confidence interval? Range of return means what? We are talking about gain here. Okay. When we are talking about gain with 95% confidence interval, it is telling you that it is going to lie somewhere between here in the minus 2.5 or 2.6% of your distribution. Okay. So maximum of the time, you can say that your whole data set is going to give you the gain within that particular range. Okay. The highest it will go till 2.6, the lowest it will go till 2.5. Now making sense?
Yes. So basically we are predicting that your loss is going to be maximum at 2.6 and your profit is going to be maximum 2.6 and the loss can be, the maximum loss that you can have is minus 2.5%.
You can also correct. So it is because we are capturing that in the gain column. Okay. And in future, that is a very good thing you have said. Because as of now in the data set, we are having 1700 entries, right? What I told you that whatever predictions or parameters we are going to find here, that is going to be same for the population as well. So you can say average, on an average, you can have 2.6 of gain. On an average, you can have minus 2.5% of or 2.5% of loss. Okay. About import it right down here. Okay. So you just need to import it once. From Stata, import stats. Okay.
Okay.
Chalo, quickly find it for the BML guys and give me the range for BML. दिया है क्या किसी ने? हाँ, मिल गया. Sorry guys, you already received 3 answers. Now let me write it down for you as well. Very simple guys. You are having the BML data set, simply write BML underscore DF underscore CI equals to stats dot normal dot interval. 0.95 is going to be my confidence interval. And then mean. Oh, that's going to be guys, from the next lecture, we will be starting with the hypothesis testing. Okay. I'm suggesting you not to miss it. It's a very important topic and it is going to be new for old batch and new batch both. Okay. Standard deviation, if I see the PML. Okay, it is somewhere coming near about minus 5% of gain and plus 5.2% of minus 5.15% of loss and 5.25% of gain. Okay, so we can say that gain of BML remains between this particular range with 95% confidence interval. Okay.